Now let's see another example. This time around, we are going to see an example that involves clearing obstacles, involving routes, but not like the first one. In this case, the route does not cover the divisor. In the last example we had that contained the root covered both the dividend and the divisor. In this fourth example, the root covers only the dividend. This is also a special case. Let us see how to go about it. Please look at the question. Square root of 2y plus 3 all over 4 minus 1 over 3 is equal to 11 over 12. In this given equation, we sense that if we have to solve it, certainly there will be a time we're going to clear divisor. At least we have three divisors here, 4, 3, and 12. And none of them is 1. Even if others are 1, and one of them at least is not 1, we still need to clear divisor. So 4, 3, and 12 will be made to become 1. So the first scale we intend to apply, if it is free for application, is to make divisor become 1. Then we're going to expect that there will be a time we make adder become 0. Of course, this y, as you can see here, currently has 3 as its adder. As we start to solve, as we continue solving this equation, we might come to a point where the adder is no longer 3. But for now, the adder to that y is 3. So that no matter what it is afterwards, there will be a need to clear the adder and make it become 0. What about coefficient? Y in this expression has 2 as its coefficient instead of 1. There will be a time whether we're going to clear coefficients to make it become 1. Whether it continues to be 2 as its coefficient or something else turns out to be its coefficient before we finish solving it, it has become clear that there will be a need to clear coefficient and make it become 1. Now let's make progress. Let's try to apply the first one, which is making the divisors become 1. Is it free for application? Yes. If this root had covered everything, including the divisor, it wouldn't have been possible for us to start making the divisor become 1 right away. But for now, we can start right away because this divisor, which is 4, under this y, is free. It is not enclosed in a common root. Neither is it enclosed in a common square or a common power. Right now we can apply it. So what is the LCM of 4, 3, and 12? It is 12. So to clear the divisors and make them become 1, we multiply each term of this equation by that LCM. This equation has 3 terms already. This is 1 term. This is 1 term. This is 1 term. So there are 3 terms here. Each term we multiply 12. Look at how 12 is multiplying the first term. Look at it here. 12 is multiplying this expression or this term. This one too times 12. See it here. This one also times 12. See it here. So what is going on here? Divisor is being made to become 1. Let's simplify each operation. When 4 divides 12, the answer is 3. Then 3 times the dividend, which is 3 times root of 2y plus 3. Please, this 3 here is 3 times whatever is here. If this 3 had been inside here, it would have been called cube root. But because it is outside this root sign, It is 3 multiplying this square root that it has come to be. Okay, so out of here, we get this. Out of this expression, we get this 4. How? It is because when 3 divides 12, the answer is 4. 4 times 1 is this 4. And minus have been there before. That's how this minus came to be. Students, I hope you know what is happening here. You know what led this expression become this minus 4? Certainly you should. Let's go on, please. What about this expression? Do you know how it became 11? Let's see it again. When 12 divides 12, the answer is 1. 1 times 11 is 11. Therefore, the whole of this expression, when simplified, will become what it is right now. Both sides have been simplified. Now, we have finished making the divisors become 1. The next is to talk about the adder. The main adder we are targeting to make 0 is this 3. We know that this minus 4 is also an adder. But when we say adder, we say an adder to the unknown. This is an adder to the left-hand side, to the whole left-hand side. But this 3 is an adder to the unknown or the variable. So at this point in time, we have two adders, minus 4 and plus 3. The main adder we want to make become 0 right now is this plus 3. But unfortunately, it is impossible to make it become 3 to become 0 because it is enclosed in a common root. Because it is enclosed in a common root, it is practically impossible to isolate this plus 3 and start making it become 0. Based on that, this root has to be first removed. And it is only when that root is removed that 2y plus 3 will now be seen as two separate terms. But as it is now, because 2y plus 3 is enclosed in this common root, we look at 2y plus 3 as being one term. Therefore, the next thing is to make this adder 3 become 0. To make it become 0, this root must go. And if a root must go from a side of equation, it must be alone, or it must be a part of a single term in one side of equation. A root must be a part of the only term that exists in one side of equation. Unfortunately, 3 root 2y plus 3 is a term, and minus 4 is also a term. It thinks, therefore, that this minus 4 should be removed to make this become a term. And if this becomes a term, what now happens is that since root is now a part of it, it can start being treated. Therefore, this adder is not the main thing we want to convert to 0. But since it has come to be an obstacle to the main adder, which is plus 3, we have to clear it first. See how it is being cleared. As before, we have to add to it its additive inverse, which is this plus 4 here. This plus 4 is a foreign number, a number just introduced to achieve that goal of making this minus 4 become 0. Minus 4 plus 4 is 0. That's the target. This 4, which was introduced here to make it become 0 here, is also written in this place to be 11 plus 4. Because of that, we say 3 root 2y plus 3, which comes out of this one, then plus 0 is the same thing. Then right-hand side, we have 11 plus 5 is equal to 15. Now, we have removed this adder. We have made it become 0, just like we have done always in making an adder become 0. But do not forget that this minus 4 is not the main adder we want to convert to 0. Instead, it is the adder to the y, which is the unknown. Right now, let's make progress and see what it turns out to be. Now that we have 3 root 2y plus 3 is equal to 15, the left-hand side is no longer having that adder it used to have. It is now time to think about how to remove this adder. The adder in this case is this plus 3. Now that obstacle, which was minus 4, has been cleared. At this point, please, don't forget that the main adder we are targeting to remove is this plus 3. That minus 4, which we removed before to make it become 0, was not the main target. It was an obstacle, and now it is out of the way. We still have another obstacle. At this point, we can even do without this obstacle, but to simplify issues, it is good that that obstacle is seen as an obstacle. This is this 3, which is this 3, which is here, serving as this 2 plus y, 2y plus 3's coefficient. That is, this 3 is serving as what? Coefficient to 2y plus 3. That coefficient 3 is preventing this other 3 from being removed. We can as well wish to remove both these 3 and this root at the same time. It is allowed, and it is discovered to be mathematically correct to remove a root and this coefficient at once. It is still practicable to remove the coefficient first and convert it to 1 and later come back to get the root off. We choose this second option. That is, get that coefficient off first to make it become 1 before we come back and make the root go off. This 3, therefore, must be made to become 1. This is why both sides have been divided by 3. When 3 divides 3, it is 1 here. When 3 divides 15, it is 5, leading us to root 2y plus 3, that is square root of 2y plus 3 is equal to 5. That means that from this operation, we get this. From this operation, we get this. Don't forget that all we have been doing for quite a while now has been maximally how to get obstacles cleared. We have been trying to clear obstacles to make this next skill applicable. That is making this adder, which is 3, become 0. Minus 4 was preventing it. Minus 4 has been cleared. Now, this 3 is still preventing it from taking place. 3 is being cleared as another obstacle. Now that we have it at this point, is it now time for us to clear this obstacle, this adder, and make it become 0? Not yet. Why? This square root is still a common square root to 2y plus 3. If 2y plus 3 were to be alone, it would have become practicable to just attack this plus 3 and make it turn to 0. But as it were, it is enclosed along with 2y in a common root. Now it is time for us to remove this root to give way for removing this adder. To get root out from any side of the equation, we must ensure that that root is either alone on one side of the equation, or that root is a part of the only single term found on one side of the equation. Which means that even at this level, we would have gone ahead to remove this root because it is only a part of a term of this left-hand side. And right now, it has become this root has become the only thing existing in this left-hand side. It is ripe, the right time to remove this root. How do we do it? To remove roots, we use powers. And to remove powers, we use roots. It is this square root we want to remove. What do we use? Power 2. See it here. This power 2 of this root will give us that same number without any more root enclosing it, which means that this 2, which is power of this square of this square root of 2y plus 3, is what produced this 2y plus 3. If you watch this expression and this expression, you will discover a difference. That is something new. That new thing is this 2. It came from outside. That number is an external or a foreign number, a number that was brought in to achieve a goal. What goal? To let this root go away. And at this level, we see it, that it has gone. Since this 2 was introduced to make this root go away, that means the value of left-hand side has changed. Consequently, the same 2, power 2, must be introduced to the right-hand side. See it here. That 5 is also raised to power 2. Since power 2 was introduced to the left-hand side of this one. Now we have this line. What is happening there? The same obstacle of this root is being removed at this line, at this point. Now simplifying both sides, this will produce 2y plus 3, and 5 to the power 2 will produce 25. This way, both sides have been simplified. Students, how many things have been done to ensure that this next skill, which is making adder become 0, have been applied? The main adder we are talking about is not any other adder we have met before, but this adder, which is 3, which has always remained with this 2y to this point. We have seen up to 3 obstacles. Recall, we removed obstacle minus 4. Then, next obstacle was this 3 as coefficient. The third obstacle is removing this square root. Now at this point, we have removed 3 obstacles that have been making it difficult and even impracticable for us to remove this adder and make it become 0. Right now we have 2y plus 3 is equal to 25. Has time arrived for us to get this adder out and make it become 0? Surely the time for it has come. There is no other obstacle there. 3 is no longer enclosed in a common root. 3 is not enclosed in a common power. And now it is time to get it out. Let us see how it is done. By now, you must have become conversant with how to make adders become 0. Plus 3 must become plus 0. See it here, plus 3 minus 3. So this left-hand side and this left-hand side compared. What is new? Minus 3 is new to this left-hand side, which means it is newly introduced. It is newly introduced to achieve a goal. The goal of converting this plus 3 to minus 3, to 0. Let's go on. That means 2y plus 3 is equal to 25. We give us 2y plus 3 minus 3 is equal to 25 minus 3. What is happening here? Adder is being made 0. Let's see what it turns out to be. After simplifying the left-hand side and right-hand side, we have 2y is equal to 22. And now we have just one obstacle remaining. So far, the toughest has been how to get the actual adder removed, which is that plus 3, to make it become 0. 3 obstacles were removed before we eventually came to apply that skill. This is exactly what this example is starting to highlight. All right, the last skill we want to apply is to convert the coefficient to 1. Because if you watch this, 2y is equal to 22, you discover that just one obstacle is remaining, and that is 2 as coefficient instead of 1. How do we do it? As before, divide both sides by these 2. See it happening here. 2 dividing 2, 1. 1 times y, y. When 2 divides 22, the answer is 11. So what is going on here? Coefficient of 2 is being made to become 1. At last, simplifying both sides will yield this result. Y is equal to 11. And that is solution to that equation.